Hello! Today we're going to be covering 3.3, writing functions. We talked about relations and functions yesterday, so now we're going to write ourselves some functions. The goal of today's lesson is to identify independent and dependent variables, and then we're going to write an equation in function notation after we learn what that is, and evaluate a function for given input values. So let's get to it. Number one, we have to determine a relationship between x and y values from this table I have here. And so the top rows are x values, the bottom rows are y values, and then we need to write an equation. So let's talk about the relationship that we can find between them first. And I want to look at, I want to find a relationship that is happening between 5 and 1. So that's the first column there. And I can easily spot two different things that we could say is happening. We could say that 1 is being subtracted from 5, so 5 minus 1 equals 4. And we could also say that 5 times 1/5 is 1, because 1/5 of 5 is equal to 1. So those are two different relationships that are happening there. But we are looking for the same relationship to be happening in every single column here. So now, do either of these relationships that we just found match the relationships happening in any of these other columns? Well, let's look at our first relationship, that 5 minus 1. So this one would have to be 10 minus 2, and we would need that to equal 4. But we know that does not equal 4. So let's look at the times 1/5. 10 times 1/5 equals 2. We know that that is true because 1/5 of 10 is 2. So let's look at the last two columns quick, just to prove what we're saying here. 15 minus 3, that doesn't equal 4. 20 minus 4, that doesn't equal 4. Over here on this side, we were multiplying them by 1/5. 15 times 1/5, that equals 3. 20 times 1/5, that equals 4. So the first column here with this relationship, that does not work. However, multiplying the x values times 1/5, that does work. So now that we've determined our relationship, we need to write an equation. And I wrote down our relationship here that we decided to go with. And writing an equation for this, we need to first ask ourselves, what does this say? What does this right here say? So how can I write an equation from that? Well, how I read it, I would say that 5 times 1/5, 5 being our x value, so our x value times 1/5 equals our y value. Our x value times 1/5 equals the y value. So then we're just going to take out the words and put in our variables and our operations. So y is equal to 1/5 x. Easy peasy lemon squeezy. So I want to talk about input and output now. Input of a function is called the independent variable. This can also be thought of or also called your x values or your domain. Likewise, the output of a function is called your dependent variable. This can be thought of or also called our y value or our range. So now we need to take these situations and determine what our independent and dependent variables are. A painter must measure a room before deciding how much paint to buy. I want to reword this as in this action depends on this other action. And so if we look at it, a painter must measure a room before deciding how much paint to buy. So the amount of paint that we need to buy, that depends on the size of the room. The amount of paint depends on the size of the room. Meaning that our independent variable is the size of the room, because the amount of paint, that's dependent. It depends on the independent variable. Independent variable, room measurements, dependent amount of paint. Let's look at one more. Excuse me. The height of a candle decreases d centimeters for every hour it burns. And I didn't have this right here. So the statement that we want to make is the height of the candle, it depends on what? The amount of hours that it's burning. Because the more hours it burns, the shorter it's going to get. Meaning that our independent variable would be hours, because the height being the dependent variable, it depends on the amount of hours. So independent is hours, dependent, height of candle. And I think you have one of those to try on your own. And we're going to go ahead and we're going to talk about function rules and function notation now. Function rule is an algebraic expression that defines a function. You guys know what a function rule is. We're just giving it a different name now. It's a different term. Because you guys know what an algebraic expression is, correct? So if I said that Tasha earns $5 per hour to babysit, I want to know what my function rule for this is. Well, let's make an algebraic expression out of this. Tasha earns $5 per hour. I'm going to have my hours be x, so Tasha earns 5x. 5x is my function rule. And then let's talk about function notation. Do you ever see, like, in math books, and math problems, like you guys probably haven't encountered them too often yet, where it says f of x, like f parentheses x parentheses, that is what function notation is. Oddly enough, function, or f of x and y are the exact same thing. You can use them interchangeably. So don't be confused when you see f of x. They are literally the exact same thing. And I only, make you do function notation so I can confuse you because that makes my day. So if we have y is equal to 5x, we're talking about Tasha here. In the previous example, the function rule is 5x. So now I'm going to say that y is equal to 5x because I'm turning it into a function. This is a linear function. Y equals 5x. I want to write that in function notation. All I'm going to do is write f of x is equal to 5x. You see that it's the exact same thing, and I just replaced my y with f of x, and f of x being function notation. Cool. I can't wait for you guys to be confused on that. A fitness center charges $100 initial fee plus $40 per month. I want you to determine my independent variable, my dependent variable, and then write this situation into function notation. Alright, independent variable, dependent variable. What action depends on another action? One of my variables here is going to be our total cost. And if we have, so we're always going to have that $100, but we're going to be charged $40 per every month. So our month is going to be our independent variable because our total cost is going to depend on the amount of months that we are part of this fitness center. So my independent variable being months, my dependent variable being total cost. Now I want to write an equation in function notation for this. And I need to define a variable first, and I'm obviously going to go with x, I always do. And x is going to be the amount of months that we are at this fitness center. Then I need to make an equation. So $100, I'm always going to have that $100. So we have $100 plus 40 times x, because it's $40 per month. And I'm just going to say that y is equal to that because we understand that right now. We understand that this is equal to y. So y is equal to 40x plus 100. Now I want to write this in function notation. So what is the one simple step that I have to do? We need to replace y with f of x and rewrite the rest of our expression. F of x is equal to 40x plus 100. That is this situation written in function notation. Let's do one more. I'll run through it a little bit faster. So Steve buys lettuce for $1.69 per pound. I want to define my independent, dependent, and I want to write this in function notation. What depends on what? Well, the total cost that I am going to pay for all this lettuce depends on how many pounds of it how many pounds that Steve buys. So my independent variable being pounds, and my dependent variable being total cost. And I'm going to now need to define a variable. I'm going to use x. That's going to be the amount of pounds. And so writing an equation for that, I'll have y is equal to $1.69 per pound. Times x per pound. And then to write this in function notation, my last step is to change my y to f of x. So f of x is equal to 169 times x. That's all. We have 2 problems left, and now we're going to evaluate functions for the given input values. For f of x is equal to 3x plus 2 when x is equal to 7 and x is equal to negative 4. All we need to do is I want to know what this part of the equation is going to equal, 3x plus 2. What will that equal when I replace x with 7? And there's just a little tricky part on how we need to write this side over here while we're doing that, and I will show you. So, rewrite your equation first. Dylan, that includes you. Rewrite your equation first. First step. F of x is equal to 3x plus 2. I want to deal with my x equals 7 first. I am going to replace the x's everywhere in my equation. So that includes, I'm going to write a 7 here and here. Don't forget to write your 7 in here. That is important. Okay? So f of 7 now, not f of x. This says f of 7 is equal to 3 times 7, because I replaced my x with a 7, plus 2. And now I'm going to simplify. Now I have f of 7 is equal to 21 plus 2. F of 7 is equal to 23. So that's saying that when I put a 7 into my function, I came out with 23. That's why it's important that we write our 7 here. Let's do a negative 4. So I'm going to rewrite my equation. Hold on, I repeat. I'm going to rewrite my equation before I plug in my negative 4. Now I'm going to plug in my negative 4. F of negative 4 is equal to 3 times negative 4 plus 2. Simplify. F of negative 4 is equal to negative 12 plus 2. 3 times negative 4 is negative 12. Negative 12 plus 2 is negative 10. Okay, let's run through one more. Evaluate f of x equals 1/3 x plus 2 when x is equal to 600 and x is equal to negative 12. First step, I'm going to rewrite my equation. Then I'm going to plug in my numbers for x. So I have f of 600 is equal to 1/3 times 600 plus 2. And then we can reduce on our diagonals here. 600 divided by 3 is 200. So I have f of 600 is equal to 200 plus 2. And f of 600 is equal to 202. We'll do x equals negative 12. I do not know what that noise was I just made. And I'm going to rewrite my equation first. F of x is equal to 1/3 x plus 2. Replace my x with a negative 12. F of negative 12 is equal to 1/3 times negative 12. Don't forget to use your parentheses here. Plus 2. And then I can reduce on my diagonals here as well. Negative 12 divided by 3. That'll give me a negative 4. So we will have f of negative 12 is equal to negative 4 plus 2. And then negative 4 plus 2 gives us a negative 2. So f of negative 12 is equal to negative 2. And that is all today, folks.